Hello everyone, welcome to PW Gulf. So today we are going to do the recap session for the chapter Motion in a Straight Line. We have done this chapter in our classes and today we'll be revising the whole chapter in one series. Okay, so let's start. What we'll be doing today, we'll be covering what is the rest, what is motion. Okay, how can we say that a body is in rest and how can we say that a body is in motion. Then we'll be covering what is distance, displacement, speed, velocity, acceleration, etc. Then we'll be going to types of motion, uniform motion, non-uniform motion. Then further types of non-uniform motion, uniformly accelerated motion and non-uniformly accelerated motion. Then we'll do motion under gravity. And then in the last we'll be studying graphs for all the types of motion between distance time graph, displacement time graph, speed time, velocity time, acceleration time graph. We'll be doing all these graphs. And in the last, we'll doing relative motion in one dimension. So let's start our series. So very first topic is what is rest and what is motion. Okay. So if you are sitting in a car, what you will see that your passenger next to you is at rest. But a person standing on the road sees the same person is moving with some velocity. So who is correct? You or that person? When you are going in a car, and two persons are sitting in that car. For person 1, the passenger is at rest. But if I have a person standing on the road, he will say that the person is moving. So who is correct? Both are correct. Okay, both are correct. We have two different observer and everyone defines rest or motion with respect to ourselves. Okay, this observer is telling us that the passenger, co-passenger is at rest with respect to the person number 1 and the passenger is moving with respect to the person number 2. So rest and motion are not absolute. Everything is relative. Okay, everything is relative. We always study what is relative rest and what is relative motion. Nothing is absolute. For the person standing on the road, trees are at rest, but for the person moving in the car, trees are in motion. So everything is relative. Now what is rest? An object is said to be in rest if it doesn't change its position with respect to time. Okay, if it doesn't change its position with respect to time. Example, book lying on the table, a tree in the garden, everything is at rest. Okay, what is motion? An object is said to be in motion if it changes its position with respect to time. At time t1, object was here and after some time t2, when I am seeing that object, it is at some other place. Okay, so a person moving on the road, a boy running in the park, everything, a car traveling, everything is in motion. When we kick the ball is in motion. Children playing in the playground are in motion. Swing is the motion. Everything is in motion. Okay, see next. Today in this chapter, we will be doing motion in a straight line. When we do observe motion in our respect, we see motion in 3 dimensions. In the physical world, we always see motion is occurring in 3 dimensions, x, y and z. Okay, when a boy kicks the football in the ground, the football goes like this. That is a motion in 3 dimensions. But in this particular chapter, we'll be studying motion in only 1 dimension. That particle is moving only in a single dimension. Okay, only in a single dimension. So when only one coordinate is changing with respect to time, that is called motion in a straight line. It is also called rectilinear or linear motion. Okay, motion in a straight line is also called rectilinear or linear motion. Example, motion of a car on a straight road, freely falling body, drop a ball always moves in a straight line towards the earth. Okay, all these are examples of motion in a straight line. Now distance and displacement. Okay, so what is distance, what is displacement? If I have 2 points A and B, okay, so four persons are moving. Four persons are moving from A to B along these three paths. So 1, 2, 3 and 4. Okay, four persons are going from A to B along the four shown paths. This is my initial position and this is my final position. Okay, four persons are going from A to B along four different paths, 1, 2, 3 and 4. The path traversed by each particle is different. Okay, the path traversed by each particle is different. One is moving along this path, two along this, three along this and four along this. So what is distance? Distance is the total path traveled by each particle. Okay, so this d1, if this is distance d1, this is d2, this is d3 and this is d4. So all are different. Okay, all are different. Okay, distance traveled by each particle is different. Distance is the total path traveled by each particle. Okay, total path traveled by each person or each particle, that is called distance. But path traveled in a particular direction from initial to final, path traveled in a particular direction from initial to final is called displacement. Always draw a vector from initial point to final point. This will show us the distance or path traveled in only one direction, that is initial point to final point, that is called displacement vector. Okay, so displacement is a vector quantity. It is telling us that particle is going from this position to this position on whatever path. Path will tell us distance, but displacement is always the shortest straight line distance from initial to final point. So if I see that every particle or every person is going from A to B, okay, every particle or every person is going from A to B, so they are traveling the same displacement. Okay, they are traveling the same displacement. Displacement is always final, x final or final position minus initial position. Okay, let us write it like this only. Displacement is always equal to final position minus initial position. Okay, displacement is always equal to final position minus initial position. So let us do the difference between distance and displacement. So what are the difference? Distance is the length of the actual path traversed by the body from its initial to final position. So the actual path body is traveling from initial to final position is called distance, while displacement is the shortest straight line path in the direction from initial to final point. Okay, displacement is the shortest straight line path from initial to final point. It is a scalar quantity. Distance is a scalar quantity while displacement is a vector quantity. Okay, distance only has magnitude and no direction, but displacement has magnitude as well as direction. It has both magnitude as well as direction. Next, distance is always positive or zero. It can never be negative. You can never travel a negative distance. Okay, either it can be positive or it can be zero, but it can never be negative. Can you travel a distance of -5 meters? No. Okay, we can't travel it. Displacement can be positive, negative or zero, because displacement is is having a direction. We always tell the direction of displacement. If I have a displacement of minus 5 meters, it means I am going along negative x-axis. Okay, if I am having plus 5, then I am going along the positive x-axis. Okay, so it can be positive, negative, or 0. It is measured in meters. Same displacement is also having the SI unit meters, and dimensional formula for both is L. Okay, dimensional formula for both is L. So this is the difference between distance and displacement. Now let's move to speed and velocity. What is speed and what is velocity? So the rate at which distance is being traveled. Okay, so speed is rate at which distance is being covered. Rate at which distance is being covered. So if we have a particle going from A to B along any path, the rate at which the particle is covering that path is called distance. That is called distance. While velocity is the rate at which displacement is being covered. Okay, rate at which displacement is being covered. Rate at which displacement is being covered, that is called velocity. Okay, that is called velocity. So if my particle is going from A to B along 3 paths, 1, 2 and 3, so distances will be different, speed will be different, but if they are all taking the same time, velocity will be same. Okay, so when we talk about distance by time, that is called speed. Okay, rate at which distance is being covered, that is called speed. Distance by time. Okay, distance covered by time taken. While for velocity we have displacement by time. Okay, rate at which displacement is being covered, that is telling us velocity. Now if I tell you that particle is covering 5 meters and you ask in which direction, then we have to tell displacement. Displacement will tell us direction. But suppose a particle is moving and other particle is also moving, how can you differentiate which is moving faster, which is moving slower? With the help of speed and velocity. So rate at which the particles are moving will be given by speed and velocity. Okay, let's differentiate these. So what is speed? The rate of change of position of a object with time in any direction, because paths can be in any direction. That is called speed. And the rate of change of position in a given direction. Which direction? Which direction? Initial to final. Initial to final, that is called velocity. Okay, it is equal to distance traveled by the object per unit time, and it is equal to displacement covered by the object per unit time. It is a scalar quantity. Speed is distance by time, distance is scalar, hence speed is a scalar. Velocity is a vector quantity because it is displacement by time, so displacement is a vector, hence velocity is a vector. It has only magnitude and no direction. It has both magnitude and direction. It has both magnitude and direction. It is always positive or 0. It can never be negative. See, distance can never be negative and hence speed can never be negative. But velocity can be positive, negative or 0, because displacement can be positive, negative or 0. SI unit of both is meter per second and dimensional formula for both is also LT minus 1. Okay, LT minus 1. Now see, if I have 2 points A and B, this is the initial point and this is the final point, then A to B straight line distance is called the displacement. And if I have many paths, D1, D2, D2 is this only, second path is the same as displacement, straight line, and D3, okay. So D1, D2, D3 are the three paths going from A to B, okay. When we are going from A to B, and going from A to B, this will be my displacement vector, okay. How to define displacement vector? If this is my initial, this is my final point, always draw a vector from initial to final. This is called the displacement vector, okay. Always draw a vector from initial point to final point, that will give us the displacement vector of that particle. Now we have three paths. Now can distance be less than displacement? Displacement is the shortest straight line path between initial and final. Any path you can take other than this, it will always be greater in magnitude. So what we have is distance is always greater than or equal to. If we travel this same straight line distance only, then distance will be equal to displacement. So distance is always greater than or equal to magnitude of displacement. And so similarly, or by the same path, we have speed will always be greater than or equal to the velocity, okay, magnitude of velocity. So speed will also be always greater than or equal to the magnitude of velocity, and distance will be also always greater than or magnitude of displacement, okay. So this is what we have. Now let's move to types of speed. What are my types of speed? Uniform speed and variable speed or non-uniform speed. If my speed is constant, that is particle is covering the same distance in same intervals of time. In 1 second it covers 5 meter, in next 1 second again 5, in next 1 second again 5, again 5. So that is called the constant or uniform speed. When speed is constant, it is called the uniform speed. A body is said to be moving with uniform speed if it covers equal distances in equal intervals of time, okay, equal distances in equal intervals of time. Or we can draw it like this. If at t is equal to 0, here it is at t is equal to 1, t is equal to 2, t is equal to 3. All these are 5 meter, 5 meter, 5 meter. So body is covering equal distance in equal interval of time, or it is moving with uniform speed. Now suppose body is at t is equal to 0 here, t is equal to 1 here, t is equal to 2 here, and t is equal to 3 here, okay. So if this is my 2 meter, this is my 5 meter, and this is 4 meter, okay. So body is covering unequal distance in equal intervals of time, okay. First it covered 2 meter in 1 second, then 5 meters, then 4 meters. So when the body is covering unequal distances in equal intervals of time, then it is called non-uniform speed or variable speed, where speed is not constant, okay, where speed is not constant. Such is called uniform or variable speed. Next is average speed and instantaneous speed, okay. So average speed is the speed over a interval of time, okay. It is defined for over an interval of time, okay, over an interval of time. So what will be my average speed, okay? V average is equal to total distance traveled by total time taken, okay. Total distance traveled by total time taken, that is called average speed. Okay, if my body is covering the motion with some 5 meters in 1 second, then 8 meters in next one, then 10 meters, then 4 meters, so it is moving with non-uniform speed. When body is moving with non-uniform or uniform speed, the total distance traveled by the body divided by the total time taken will give us the average speed over the time interval. So if we write v average, it will be equal to total distance. If my total distance is delta x or delta d or anything change in the position of, and total time is delta t, so it will be delta x by delta t. This will be my v average. Now what is instantaneous speed? Speed at any particular instant of time. Okay, instantaneous speed is speed at any particular instant of time. Okay, speed at any particular instant of time. Now if I say you what is the speed at 4 seconds, so you have to tell the speed at 4 seconds, not any interval. How can we get a point of time if we are moving with a variable speed? Suppose this is my distance and this is my time axis, and I am moving with some variable speed. If I check this, it will give me the interval. Okay, it will give me that how much distance I have covered in how much time. Okay, this is defined over a interval delta t. If I make this delta t so small, okay, if I make this interval so small like this, then I'll get a particular instant of time. Okay, if I make this distance, if I make this interval very small, very small, such that it is almost zero, then we'll get a point of time. Interval is t2 minus t1. Reduce it so that it becomes so small, so that we get a point of time. That will be my instantaneous speed at that point. So if it is covering delta x by in time delta t, so v instantaneous will be limit delta t tends to 0 delta x by delta t. Okay, v instantaneous will be speed divided by time, but with the condition that time interval is almost 0. Okay, it is tending to 0 when we have delta x by delta t such that delta t is very small. What will this become? This becomes dx by dt. Very good. This becomes dx by dt. So this will be my instantaneous speed and this will be my average speed, total distance traveled by total time taken. Okay, this will be my average speed. Okay, this is my instantaneous speed. Total distance instantaneous speed is dx by dt and in average speed is delta x by delta t, total distance by total time taken. Now see types of velocity. Again we have uniform velocity. How my velocity will be uniform? If it covers equal displacement in equal intervals of time. In 1 second it displaces by 5 seconds, then 10 seconds, and then again in 1 second by 5 meters. Suppose my particle is moving. In the first second it do a displacement of 5 I cap, okay, in x direction. Next 5 also 5 I cap. Next also 5 I cap. Next also 5 I cap. Then it is doing equal displacement in equal interval of time. So then it's said to be moving with uniform velocity. It means velocity is constant. Now velocity is a vector, which means magnitude is also constant and direction, both are constant. Okay, both are constant. Then we can say that velocity is constant. If my magnitude changes or my direction changes or both of them changes, then velocity will change. It is not. See, displacement of 5 I cap is never equal to displacement of 5 j cap. Displacement has a direction. Okay, so what is variable velocity? It is variable if it either speed changes, direction of motion changes, or both changes. Okay, either the speed changes matlab magnitude changes, or direction changes, which means direction, its motion's direction is diverted, and or both of them changes, then it is called variable speed. Okay, velocity is a vector. If any component of a vector changes, magnitude, display magnitude or direction or both of them, then the vector will change, so velocity will change. Such a velocity is called variable velocity. It means unequal displacement in equal intervals of time. Again, average velocity. So what is my average velocity? Over a interval of time, over an interval of time. Average is defined over an interval of time. So V average is equal to total displacement divided by total time taken. Okay, it is defined as total displacement by total time taken. So V average is equal to delta S vector, if delta S vector is my displacement, divided by delta T, or if it is in one dimension, then we can write it as delta X vector by delta T. Okay, this is my V average, total displacement by total time. What is instantaneous? Velocity at any particular instant of time. Okay, velocity at any particular instant of time is called instantaneous velocity. Okay, at any particular instant of time, t is equal to 3 seconds. Again, to get a particular instant of time, what we will do, make the interval very small. So when we write v instantaneous, we have to make delta t very small. Okay, we have to make delta t very small. So apply limit on average velocity, that it is delta x by delta t, where delta x is my displacement done in time delta t. But here we have a condition that this delta x displacement is done in time delta t, but delta t is very small, it is almost zero, so that we get a instant of second. Okay, instant of time. So v instantaneous, limit delta t tends to 0, delta x by delta t will become dx by dt. Okay, it will become dx by dt. So this will be our instantaneous velocity. Okay, this will be our instantaneous velocity. Okay, now let's come to different cases of average speed. How to find average speed in different cases. First case is when body covers different distances with different speeds. So first, let us take that body is going from A to B. Okay, body is going from A to B and it moves with V1 speed for S1 distance, V2 speed for S2 distance, V3 speed for S3 distance. Okay, it is moving with V1 speed for S1 distance, V2 speed for S2 distance, and V3 speed for S3 distance. Now time taken to cover this distance, S1 will be S1 by V1. Time taken to cover this distance will be S2 by V2, and lastly time taken to cover this distance will be S3 by V3. Now what is my V average? V average is total distance by total time. Okay, it is total distance by total time. So what is my V average? V average is equal to total distances S1 plus S2 plus S3. And what is my total time? It will be T1 plus T2 plus T3. Okay, it will be T1 plus T2 plus T3. Now again, substitute the value of T1, T2, T3. V average will be S1 plus S2 plus S3 divided by T1 is S1 by V1 plus S2 by V2 plus S3 by V3. So this will be my average speed. Okay, this will be my average speed when body moves with S1 distance with V1 speed, S2 with V2 and S3 with V3. Okay, see next, when body moves with different speeds in different time intervals. So a body is moving from A to B, and for time T1 it is moving with V1 speed, for time T2 it is moving with V2 speed, and for time T3 it is moving with V3 speed. It is moving with different speeds for different time intervals. Again we have, what will be my V average? It will be total distance by total time. Okay, total distance by total time. Now what will be my distance covered in going from this point to this point? S1, distance covered in time T1 will be equal to V1 into T1, and S2 will be equal to V2 into T2. Similarly, S3 will be V3 into T3. Now total distance V average will become, total distance is S1 plus S2 plus S3 divided by total time is T1 plus T2 plus T3. Substitute the value of S1, S2, S3. We will get that V1 T1 plus V2 T2 plus V3 T3 divided by V1 T1, oh sorry, divided by T1 plus T2 plus T3. Okay, so this will be my average speed. Okay, this will be my average speed in this case. Clear? So what we have is, when particle moves with different speeds for different time intervals, V average will be V1 T1 plus V2 T2 plus V3 T3 divided by T1 plus T2 plus T3. We always have to use that basic formula, total distance by total time taken. Okay, so let's come to uniform motion. So when particle is moving uniformly. Uniformly means nothing changes. Neither its magnitude nor its direction changes. So when particle is moving with constant velocity, okay, when particle is moving with constant velocity, then it is called uniform motion. Okay, when the particle is moving with constant velocity, then it is called uniform motion. So let us see what is uniform motion, in which the object travels in a straight line, its velocity remains constant, and it covers equal distances in equal intervals of time irrespective of the time interval. In this case, particle has to move in a straight line, so distance will be equal to displacement because velocity will be constant. Okay, velocity will be constant, v constant, which means magnitude is constant, magnitude is constant, and direction is also constant. Okay, direction is also constant, direction is also constant. So we classified motion into two types. We classified motion into two types. One is the uniform motion and other is the non-uniform motion. Okay, one is the uniform motion So what is my uniform motion? In which velocity remains constant. And the other one is the non-uniform motion, in which velocity is not constant. Okay, in which the velocity is not constant. If my velocity is not constant, it means it is changing. So the now we want to know at what rate my velocity is changing. So here v vector is a constant and here v vector is not a constant. Either magnitude or direction or both can change. Okay, so when my particle is moving with non-uniform velocity or doing non-uniform motion, velocity is changing. Now we want to know at what rate my velocity is changing. Okay, now we want to know at what rate my velocity is changing, how it is changing. So here comes another quantity in non-uniform motion, in which the object travels with varied velocity. It does not cover the same displacement in equal time intervals. Okay, it doesn't cover the same displacement in equal time intervals. Velocity is changing. So either v vector is changing or variable. So what can be variable? Either magnitude can change, either magnitude changes or direction changes or both of them changes. Okay, or both of them change. Okay, so then it won't be constant, and such a motion is called non-uniform motion. So when my velocity is not constant, it is changing with time. We want to know how velocity is changing with time. So here comes the another quantity, acceleration. Okay, acceleration. So what is acceleration? Rate of change of velocity of an object is called acceleration. Okay, so what is my acceleration? Acceleration is equal to rate of change of velocity. So we will have change in velocity divided by time taken. Okay, acceleration will be equal to change in velocity divided by time taken. Now what are its property? It is also a vector quantity. It also has magnitude and direction both, and it can also be positive, negative or zero because it is change in velocity. Unit will be meter per second square and dimensional formula will be LT minus 2. Okay, so this is acceleration. Now let's do types of acceleration. First is uniform acceleration. Uniform means constant. So when velocity changes by equal amount in equal intervals of time, it means acceleration is constant. Okay, it means acceleration is constant. Velocity in 1 second it increased by 5 meter per second, in another second again 5, again 5. So it is changing at a constant rate. Variable acceleration, if its velocity changes by unequal amount in equal intervals of time, then it is variable acceleration. So what we have is when acceleration is not constant. When acceleration is not constant, it is called variable acceleration. Okay, in first second it changed by 3 and in next second it changed by 8 meter per second. So it is not constant. Okay, so this is how we define uniform and non-uniform acceleration. Then again comes average acceleration and instantaneous acceleration. So average acceleration will also be over an interval of time. It is also defined over an interval of time, and average acceleration will be equal to total change in velocity, total change in velocity divided by time taken, divided by time taken. So from here we can define A average will be equal to V final minus V initial, or let's take it as V2 minus V1, V2 minus V1 divided by T2 minus T1. Okay, if at T1 velocity was V1 and if at T2 velocity is T2 V2, so it will be V2 minus V1 divided by T2 minus T1. So A average will be delta V by delta T. Okay, delta V by delta T. Now let's see what is instantaneous velocity at acceleration at any particular instant of time. Okay, acceleration at any particular instant of time is called instantaneous acceleration. Now again, to get an instant of time, make the interval very very small. Okay, again to get a instantaneous will be equal to limit delta t should be almost 0, delta v by delta t. Okay, now what will be my delta v by delta t? Limit delta tends to 0, it will become dv by dt. Okay, it will become dv by dt. So from here, instantaneous acceleration will be dv by dt. Okay, dv by dt. Clear? So from here we can define instantaneous acceleration. Now let's see what are relations between distance, displacement, velocity and acceleration. Okay, so first is we defined my velocity, or velocity is equal to dx by dt. Okay, or v is equal to dx by dt, and speed is equal to distance by time. In 1D motion, these are almost most of the cases equal only. So v is equal to dx by dt. In magnitude, if we want to see, and if we place the vector, it means then we are considering direction also. Then we had acceleration is equal to dv by dt. Okay, acceleration is equal to dv by dt. Now from this, can we write that if we want to find dx, change in position, okay, if we want to find dx, change in position, this will be equal to v into dt. So dx is the change in position in small time dt. If I want to find the total change in position, what I will do is integrate on both sides. So change in position or displacement. Okay, let us say total displacement, s vector or x final minus x initial vector, total change in displacement delta x vector, we can write it is equal to v dt. Okay, it is equal to v dt. So how can we get displacement from velocity? It will be delta x is equal to v dt, and similarly if we want to find distance, dx is equal to v dt, and distance will be equal to integration of dx, which is equal to integration of v dt. So total distance will be integration of speed into time. Okay, integration of speed into time. Now we have acceleration is equal to dv by dt. So from here we can write it as dv is equal to a dt, and for total change we will integrate both sides. So what we will get is delta v is equal to integration of dt. Okay, so total change in velocity is equal to integration of acceleration. In magnitude form we can write it as delta v is equal to a dt. Okay, it is equal to a dt. Now there is one more formula for acceleration. A is equal to dv by dt. Okay, a is equal to dv by dt. Multiply it with dx and divide it by dx. Okay, multiply and divide it by dx on both sides. What this dx by dt will become? This dx by dt will become velocity v, and what will be left is dv by dx. So from here we get one more formula, that acceleration is equal to v into dv by dx. V into dv by dx. Now let's make a chart. If we have x, then differentiate with respect to time, we will get velocity, and again differentiate with respect to time, we will get acceleration. Okay, if we have in acceleration, then integrate with respect to time, we will get velocity, and integrate with respect to time, we will get distance. Okay, we will get distance. So let us write it once more. Velocity is equal to dx by dt, and change in position, change in position or displacement is equal to integration of v dt. Okay, it is equal to integration of v dt. Then acceleration is equal to dv by dt, or we can write it also as, now see once more, let's write it over here only. Acceleration is equal to dv by dt. What is v? What is v? It is dx by dt. So d by dt of dx by dt, because v is equal to dx by dt. So acceleration will become d square x by dt square. Okay, acceleration will become d square x by dt square. Double differentiation of position. Okay, this will be my acceleration. So it is d square x by dt square, or v into dv by dx, and change in velocity or delta v will be given by integration of a dt. So this is how we can go from one variable to another. Okay, this is how we can go from one variable to another. This is very, very important. Okay, this is very, very important. Now when velocity is changing, when we have non-uniform motion, okay, when we have non-uniform motion, so velocity is changing. If velocity is changing at a constant rate, acceleration is constant, and if velocity is changing at a variable rate, then acceleration is variable. If velocity is changing at a constant rate, then it is constant, and if velocity is changing at a variable rate, then it is acceleration is variable. So non-uniform motion is also classified into two types. One is uniformly accelerated motion. Okay, uniformly accelerated motion in which acceleration remains constant, and then we have non-uniformly accelerated motion. Okay, then we have non-uniformly accelerated motion in which acceleration is not a constant. Okay, so in my first case, acceleration is constant, and in second case, acceleration is not constant. Acceleration is not constant. Okay, so we have two types of motion, uniformly accelerated motion and non-uniformly accelerated motion. In first case, acceleration is a constant, and in second case, acceleration is not a constant. Now, let's see uniformly accelerated motion. So, uniformly accelerated motion, acceleration is constant, velocity changes by equal amount in equal intervals of time. Now we have equations for uniformly accelerated motion. Equations of uniformly accelerated motion. What are my equations for uniformly accelerated motion? If u is my initial velocity, okay, u is my initial velocity, u is my initial velocity, v is my final velocity. Initial velocity means at t is equal to 0, okay, t is equal to 0, and at any time later t, at any time later t, v is my final velocity, a is my acceleration, okay, a is my acceleration, s is my displacement, s is my displacement. Then what are the equations of uniformly accelerated motion? V is equal to u plus at, v is equal to u plus at, s will be equal to ut plus half a t square, s will be equal to ut plus half a t square, and then v square minus u square will be equal to 2as, okay, v square minus u square is equal to 2as, and one more s nth. S nth is the displacement in nth second, okay, s nth is my displacement in nth second. Like if I say what is the displacement in fourth second, so only displacement of fourth second is what we have to consider. So s nth will be u plus a by 2 into 2n minus 1, okay, s nth will be u plus a by 2 into 2n minus 1. So this is my equations for uniformly accelerated motion. Let's put many stars on this because it is very important, okay, it is very important. So these are my equations for uniformly accelerated motion. Whenever acceleration is constant, we can apply these equations, okay. Now let's see motion under gravity. Motion under gravity. What is my motion under gravity? When body is moving under the influence of gravity, okay, when body is moving only under the influence of gravity, only under the influence of gravity, then it is called uniformly motion under gravity. Now because acceleration due to gravity is a constant, if we see it over a very small height from the earth, so we take a few assumptions that h is very less than r, the height up to which projectile is going, it is very less than r, radius of earth, and also curvature of earth is not considered, okay, curvature of earth is not considered. And one more assumption, no air drag, okay, no air drag is being considered, okay, no air drag is present. So under the influence of all these conditions, we assume that acceleration will be g acting downwards, okay, in which direction? Towards the ground, always towards the ground. Acceleration due to gravity will always have its direction towards the ground, and it is a constant. Okay, and it is a constant. So acceleration is my constant, we can use it. Okay, we can use it. Acceleration is equal to g is equal to constant. And what is the value of g we take? We take g is equal to 9.8 meter per second square, or sometimes approximately as 10 meter per second square. Okay, so these we assume that g is constant. Now because acceleration is constant, so we can apply the equations of uniformly accelerated motions. Okay, so we can, acceleration is g, which is a constant. Okay, which is a constant when body is projected upwards with the velocity u. Let's see a case 1. This is my body, it is projected with some u velocity upwards. Okay, it is projected with some u velocity upwards. What will happen? It will go up to some height, then its velocity will become 0, and then it will return back to the earth. Okay, and then it will return back to the earth. Okay, it will return back to the earth. So the maximum height, up to which body goes is h. It will take some time t in going upwards, and the same time it will take in coming downwards. So what is my time of ascent? It is u by g. And what is my time of descent? It is also u by g. Okay, time of ascent, time taken to go upwards, and time of descent, time taken to come downwards. Okay, let us take that we have taken this upward direction positive and downward direction negative. We can apply the equations and get these answers. So time of flight, total time of flight, that is time taken to go upwards plus time taken to go downwards, it will be ta plus td. So time of flight will be equal to 2u by g. Okay, time of flight will be equal to 2u by g. If my body is going with some velocity u, it will reach to a maximum height, then again it will come back. So total time of flight is 2u by g. Time taken to go upwards will be u by g, and time taken to come downwards will be u by g. What will be my maximum height? Maximum height h will be equal to u square by 2g. Okay, maximum height h attained by the body will be equal to u square by 2g. Apply the equation v is equal to u plus at to get the time of ascent, descent and time of flight, and apply the equation v square minus u square is equal to 2as to get h is equal to u square by 2g. Okay, we can apply this equation and get these answers. However, we are concerned with the formula because we have to do the numerical solutions. Okay, see next case, when body is dropped from a height h. Okay, when body is dropped from a height h. When body is dropped from a height h. So when my body is dropped from a height h, initially the body was here. Now we dropped it, so u will be 0. Okay, it is dropped, so u will be 0. Now it will move down and hit the floor with some velocity v. Okay, and it will hit the floor with some velocity v. Now time taken to come down, time taken will be equal to t is equal to under root 2h by g. Okay, t will be equal to under the root of 2h by g. apply S is equal to ut plus half at square, we will get the time taken to come down. And next parameter is final velocity. So final velocity with which it hits the ground, final velocity with which it hits the ground, this will be equal to under root 2gh. Okay, v will be equal to under root 2gh. It will hit the ground with velocity root 2gh. Apply the equation v square minus u square is equal to 2as. Okay, to get this as answer. Now let's do graphs. See which graph tells us. First we will do that. If I have position time graph, okay, if I have a position time graph, then what will be my slope? Slope will be equal to dx by dt. So dx by dt is equal to velocity. Okay, velocity. So slope of position time graph or distance time graph or displacement time graphs, these give us speed or velocity. Okay, this gives us speed or velocity. Next, if I have velocity time graph, okay, or speed time graph, if I have velocity time graph or speed time graph, then what will be my slope? Slope will be equal to dv by dt. Slope will be equal to dv by dt. So it will give me acceleration. Okay, slope will be equal to acceleration. And what is area? Area under the curve, it will be equal to v dt from t1 to t2. If I want to find the area from this point to this point, then it will be v dt from integration of v dt from t1 to t2. What is this? This is change in position. Change in position or displacement. Okay, or displacement. This will give me. So for VT graph, for velocity time graph, what we have is slope is equal to acceleration. Slope is equal to acceleration and area is equal to displacement. And area is equal to displacement. Okay. Now suppose we have a velocity time graph like this. Suppose we have a velocity time graph like this. This area is A1, this area is A2, this area is A3. Now A1 and A3 are positive, but A2 area is negative. A2 area will be negative. So what will be my distance? Okay. So distance is always the total area irrespective of the sign. It is always the total area irrespective of the sign. So distance will be magnitude of A1 plus magnitude of A2 plus magnitude of A3. Only magnitude. Don't take sign while calculating distance. Okay. Only magnitude. Only magnitude. No sign. Okay, only magnitude, no sign is taken while calculating distance. But if we want to calculate displacement, okay, if we want to calculate displacement, now because displacement is a vector, we have to take sign. So displacement will be the simply the sum of areas A1 plus A2 plus A3 with the sign. Okay, substitute the areas with the sign while calculating displacement. Okay, substitute the areas with sign while calculating displacement and substitute the areas without sign, only magnitude while calculating distance. Okay. Next is, what if we have acceleration time graph? Okay. What if we have acceleration time graph? So slope of acceleration time graph will give us rate of change of acceleration, nothing else. But if I want to find area under the curve from T1 to T2, okay, if we want to find area under the curve from T1 to T2, this will be equal to integration of ADT from T1 to T2. What is integration of ADT? It is equal to change in velocity. It is equal to change in velocity. So area under AT graph, area under AT graph gives change in velocity. It gives change in velocity. Okay, it gives change in velocity. Now let's draw the graph for uniform motion. Now let's draw the graphs for uniform motion. First we will draw the position time graph, xt graph. Then we will plot the velocity time graph. Okay, then we will plot the velocity time graph. Okay, now in uniform motion, v vector is equal to constant. In uniform motion, velocity is constant. So how can we represent a constant? It is represented like this. This will be the graph for velocity. And how will my x change? It will change linearly with time. Okay, x will change linearly. It will increase at a constant rate. Okay, it will increase at a constant rate. That this tan theta will give us slope which is equal to velocity. Okay, this tan theta will give us slope which is equal to velocity. Now because velocity is constant, so slope is constant, so graph will be a straight line. Okay, graph will be a straight line because a straight line has slope is equal to constant, and acceleration will be 0. Okay, acceleration will be 0. Now let's draw the graph for uniformly accelerated motion. Okay, for uniformly accelerated motion. Okay, uniformly accelerated motion, we have v is equal to u plus at. So acceleration is constant. Acceleration is constant. So if we draw the acceleration time graph, it will be a constant. Okay, if we draw the acceleration time graph, it will be a constant. Now let's draw the velocity time graph. Acceleration is a constant. It means dv by dt is a constant. Okay, it means dv by dt is a constant. What does slope of vt graph gives? It gives us acceleration. So slope is constant. Okay, slope is acceleration is equal to dv by dt. It is a constant. So graph will be a straight line. Then let us plot the position time graph or displacement time graph. Now position time graph will be parabolic. See, from the equation, s is equal to ut plus half at square. So s is proportional to t square. We can say that it is a parabolic graph. Okay, it is a parabolic graph. How we can check that it is acceleration is increasing? If this is my slope at 0.1 and this is my slope at 0.2. 2. This is theta 2. So what will be my theta 1 and theta 2? Because theta 2 is greater, slope will be greater. So we can say that v2 is greater than v1. It means velocity is increasing, so it is accelerating. Okay, it means velocity is increasing, so it is accelerating. For non-uniformly accelerated motion, graph will depend on how acceleration depends on time. Okay, so if we draw one more graph, if we draw one more graph like this, now let us see how, if we draw slope over here, it will be theta 1, and if we draw slope over here, it will be theta 2. Now slope is decreasing. Okay, slope is decreasing. Slope is decreasing, it means velocity is decreasing. Theta 2 is less than theta 1. Theta 2 is less than theta 1, so slope will be lesser at 1 or lesser at 2. Slope is decreasing, it means velocity is decreasing. When velocity is decreasing, so acceleration will be negative. Acceleration will be negative. Negative acceleration is called retardation or deceleration. Okay, negative acceleration is called retardation or deceleration. Okay, so this is a graph of retarding motion. Okay, this is a graph of retarding motion. For to check that velocity is increasing or decreasing, take any 2 points, draw the slopes at that points and check. If slope is increasing, then velocity is increasing, it is accelerating, and if slope is decreasing, then velocity is decreasing, it is deaccelerating. Okay, now let us move to relative motion in 1D. Suppose we have two observers. Okay, we have two observers, A and B. Both are moving with velocities VA and VB. How one moving body perceives the other. Okay, how one moving body perceives the motion of the other body is called relative motion. This is called relative motion. So if I write position of A or position XBA, this will be equal to position of B with respect to A. Similarly, VBA, this will be my velocity of B with respect to A. Okay, and if I write ABA, this will be my acceleration of B with respect to A. This is also my acceleration of B with respect to A. So when I make this A the observer, okay, when I make any moving body or observer, so this is A my is observer, then we move into relative motion. Okay, then we move into relative motion. So XBA will be equal to XB minus XA, and VBA will be equal to VB minus VA, and ABA is equal to AB minus AA. Okay, this is how we define with respect to other body. Okay, these are the equations for relative motion. Okay, relative motion. Now see, if A is moving in this direction and B is also moving in this direction, let us take this direction as the positive direction. What is VBA? It will be VB minus VA, simply because both the velocities are positive. Next, if A is moving in, if B is moving in this direction with speed VB and A is moving in opposite direction with velocity VA. We have taken this direction as positive only. So in this case, VBA will be equal to, VB is positive minus VA. VA is in negative direction. So in this case, VA will be VB plus VA. So when particles are approaching each other from opposite direction, VBA will be VB plus VA, and when they are moving in the same direction, it will be VA minus VB. So this is all about today's ultimate recap. I hope you guys enjoyed this session and whole chapter is revised. So keep studying, keep rocking. All the very best. Take care. Goodbye.